determine how A, H, and K affect the shape and position of the graph y equals A times the quantity x minus h squared plus k. So how do all these affect it? We're going to go through a series of openers that are going to allow us to determine what the behavior is. But the first thing we need to know is what we're going to refer to as the parent function, the most basic of the functions. So if we know what the basic function looks like, once we learn what A, H, and K does to it, we can just apply that to what we know of the basic function. And so, maybe I'll start here with -4, -3, -2, -1, 0, 1, 2, 3, and 4. And that will help me understand what the graph looks like. So I could plug it in. So this is -4 quantity squared, which is 16. The next one, again, I plug in x as -3. Squared gives me y, which is 9. -2 squared gives me 4. -1 squared gives me 1. 0, 1, 4, 9, and 16. And I know those not because I can do squares quick in my head, although I could, but I know what this looks like. So graphing it, I don't have -16 on my graph or +16, so I can't graph that at this point. So I'll start at -3, and -3, 9. -2, 4. -1, 0, 1, 2, 4, 3, 9, and then back to 4, 16, which isn't on the graph. So you'll notice that this is symmetric about the y-axis, meaning that it's the same on both sides of the y-axis. It's mirrored. And so I know my line of symmetry is at the y-axis, which we'll know as y equals 0 is my line of symmetry. Sorry, not y equals 0, x equals 0. X equals 0. Line of symmetry. I also know my vertex. My vertex is the lowest or the highest point of a parabola. In this case, my vertex is at 0, 0. Now, as we move forward, one question to ask yourself is, well, what is A, H, and K in this problem, so that when we see the line of symmetry in the vertex, we can start to make relationships. So A in this problem, well, let's rewrite it in that form. This could be rewritten as y equals 1 times x minus 0 squared plus 0. So hopefully by this representation you can tell A is 1, H is 0, K is 0. So that's the first opener. Obviously it's hard to draw a pattern from 1, but once we start seeing more, you might want to refer back to this parent function and see how it's different.